Hello students, welcome back. In the previous classes you have seen that we have done till question number 4 of exercise 1.1. So today we'll start with example 5. And what is the question? Let's read the questions. What can be the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. Okay. So let's divide it first, then I'll make you understand. So see 1 here, 7 is not, I'm not able to divide 1 by 17. So what I'll do, simple method, I'll take 0 here, here also 0. Okay, this one. So for this decimal point, I'll take here decimal point 1 and then I'll take 1 0 free. Alright. After I take 1 0 free and decimal point here, still you can check that 17 is not dividing 10. So for that, what is the next step? That I'll take 0, one more 0 here and then here 0. Okay, so for this decimal point 1 0, and after taking 1 0, I'm not able to divide this 10 by 17. So what I'll do, I'll take one more 0 here, and for this 0, this 0. Now I can divide 17 and 100. That is 5 times. So 85. Okay, so 100 minus 85. I can divide. I can multiply. I can minus. So this is my 15. So this is point here already decimal point. So 1 0 will be free. Okay, so 17 and 150. If I divide, I'll get 8 times. Okay, 8 into 17 is 136. 150 minus 136 is 14. This decimal point here, so 0 will be free. All the time 0 will be free. 1 0 will be free. Okay, again 17 and 140, again 8 times. 136. This is 4. Again 0 free. 17 and 42 times. 34. Okay, so 40 minus 34 is 6. So I'll take here again I'll divide this 17 and 6. I'll take this 6 here. Okay, so 6 again I cannot divide, so 1 0 is free. So 3 times now. 317 is a 51. Here 9. So 1 0 free. Alright, again 5 times. 5 into 17 is 85 minus 5 0 free 50. Again 2 times. 2 into 17 is 34. 16. 1 0 free. Okay, 9 times, because 9 into 17 is 153. 7. So 0 free again. So again I'll divide here 17 and 70. Okay, so 4 times. 17 into 4 is 68. 2 0 free. 1 time. 17 3 0 free again 1 time. 1 into 17 is 17. 13 again 1 0 free. Okay, are you understanding? Tell me now, 17 and 30, how much time you can divide? Okay, so 7 times, because 17s are, you can divide 7 7s are 49. 4 7 1 7 4 11 1 1 9. So 11 again 1 0 free. This 0 is free because of this decimal point. Is that clear? So let me rub this. $17 and 110. Okay, so 7 times again 6 times, it will go 6 times. 6 17 is 6 7 is 42. 6 1 is 6 plus 4 10 102. 8, and because of this decimal point 0 is free. Okay, again 4 time. Let me rub this also. Okay, 4 time. 4 7 4 6 4. Okay, again this 17, how many time it will go? 4 time again. This is 68. 1 2 0 free. Okay, 7 time. 7 17s are 119. So 1, this point 0 free. Now see the twist. 17 and 10, can I divide it? No. So again I'll get 0 and one more 0 here. Again 8 time, 5 time. 5 17s are 85. I'll get here 15. So again let me divide 17 and 15. So again this decimal point, see, this will continue. 150. Okay, 8 time. 136. Okay, 140 free. Okay, so I'm not doing further because this is repetitions. 058. See, 058 again. If you keep on dividing, you'll get the same repetition of numbers. 058. See, 058 8 2 3 5 2 9. See, this is the repetition because 140 again you'll get 136. Again after subtraction you'll get 40, again 30. So this is again repetition, so I'm not going to do further. So till this much I'll keep. So that means what I can write. Let me rub little bit of it. Okay, so thus 1 by 17, if I divide I'll get 0 0.058823529417647. Okay, again I'll get this 058 dot repetition. So this will be my like this 0.058823529411767. This I'll put the bar on top of this because after this the number will repeat again. So this is the long division process, which is very lengthy, but still I have shown you. So after that, what was the question? The question asked was, I have to divide a long division method and to check my answer. So therefore, by long by long division, the number, see, after digits, I mean after decimal point, how many digits are there? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So the number of digits in the repeating block, repeating block of digits in the decimal expansion, in this decimal expansion, in the decimal expansion of 1 by 17 is equals to 16. No, I have 16 number of digits after decimal point. Therefore, the answer is verified. Okay, so this is question number 5. Let's do question number 6 also. Okay, what is the question number 6? Question number 6. Look at several examples of rational numbers in the form of p by q. So that means we have to write some rational number in the form of p by q. Obviously, rational number is in the form of p by q only, and q should not be 0, where p and q are integers and with no common factors other than 1. So see this one, there are three parts. First part is this rational number in the form of p by q. Second part, the number which will take in the form of p by q, we should have only one is common factors. Okay, only one should be a common factor. Third part is and having terminating, and when you divide you should have decimal representation, that is terminating, stopping. Okay, so three conditions. First condition, rational number. Second conditions, one should be your common factors in both the numerator and denominator, and third condition, it should be terminating, decimal expansion should be terminating. Okay, so focusing on this, let's start this sum. So solutions. Okay, solutions. Number one, you can take any number. Okay, just you should keep in mind that it should be a rational number in the form of p by q. Yeah, it is p and this is q, and q should not be 0. Yeah, obviously q is not 0, so first condition is satisfied. Second conditions, it should not have common factors other than 1. Yes, see, 1 I can add 1 into 1, and 2 I can add 2 into 1. So my common factors here is equals to only 1. Here 1 and this one, common factor in both the numerator and denominator is 1. Other than 1, I do not have any common factors. So 1. Condition 2 is also satisfied. Terminating. So this terminating I have to see. Means I have to divide this and I should get some decimal expansion in terminating form. Okay. So let's start. So this one I can write equals to 1 by 2 into, so I'll multiply the denominator with some number, with that kind of number which makes me division easier. For example, if I take 5, I'll get 10 in the denominator and my division will become easier. So 5 I'll take here also. It's a rule that if I divide the denominator with some number, the same number should be multiplied in the numerator also. So I have taken 5 to make the denominator easier in terms of zeros. So 10. So 5 ones are 5. That means if I divide, I'll get 0.5. See, the third condition also satisfied. Terminating. It is terminating. Stopping. Ending. Number 2 example. Take anything, any number. You tell me 3 by 4 for example. So 3 by 4 I can take 3, because 3 by 4, 3 into 1, 4 I can take 2 into 2 into 1. That is 1 is the common factor. So second condition also satisfied. First condition also satisfied. Third condition, it should be terminating. So yeah, obviously it will be terminating. How? 4 into with what number I'll multiply so that I'll get zeros in the denominator. Obviously I'll take let's take 25. It will be easier for me because I'll get 100 here. For me to divide, it will be easier. So here also I have to multiply by 25. So 3 25s are 75. So this is 0.75. Okay, is it clear? Let's take some more example. Example 3. 31 by or 3 by 20, take any number, 25. So this is also 1 multiply, this is 1. That means first condition satisfied, or second condition satisfied. First condition is this is p by q. Second condition, yes, 1 is the prime factor because we do not have more than 1 as a common factor, because 31 I can write 31 into 1, and 25 I can write obviously 5 into 5 into 1. So 1 is my common factor. Common factor means a number which I can have in both the numerator and denominator. Okay, so this one 31 by 25. So with what number I'll multiply so that I'll get zeros in the denominator? For example, 100. Obviously 425 is a 100. So into 4 here also. 4 ones are 4, 4 threes are 12. So that is, if I divide, I'll get 1.24. And this part, how I am getting this? Just remember that the denominator I have 2 zeros. So in the numerator also, counting from right hand side, after two digits you will have point here. That means 1.24. 2 zeros counting from right hand side, after 2 digits I should have 0.75. Before that I should have point. See, Here 10, only 1 0. That means from right hand side, if I count after one digit, I should have a point. Before 5, I should have point. So this is how we divide by any number having zeros. Okay, like 10, 100, 1000, like that. So number 4 also, let me take one more example. 13 by 25 equals to 30. You can take any number. Okay, just it should satisfy the condition. First condition, you should have only one as a common factor. See, I am having here one, here also one is a common factor. This is second condition. First condition was a p by q. See, p and q, p by q, and q is not 0. So second condition was satisfied. So now I am trying to fulfill the third condition. So what I'll do, 25 I'll multiply by 4. Okay, I'll multiply by 4, that is 100, and this one 3 4s are 12, 4 1s are 4, 5. So this is 0.52. Okay, so anyone you want to know any more examples? Many examples are there. Let's take the last example, 13 by 20 example. So this is 13 by 20 into 5. This also 5, 65 by 100. So 0.65. Okay, so this is the third condition. So what is the question? So having terminating decimal, yes, I'm having terminating decimal. See, 0.5, 0.75, 1.24. Representations, expansions. Can you guess what property Q must say? Okay, what is the property that Q must satisfy? See here, what is the Q here? Q here is, when I take 1 by 2, Q is 2. Here, what is Q? 4. Q is equals to 4, that is 2 square. Okay, and here, what is Q? Q will be 5 square. 5 into 5, that is 5 square. All right, here also Q is 25, that is again 5 square. That means what I am having, 2 5 2 5 5 2 5 5. And here, what is Q? Q will be 2 square into 5, means both 2 and 5. Here 5, here 2. Okay, so the property that Q must satisfy is that the prime factorization of Q, this is a prime factorization of Q, must have power of 2. Okay, power of 2 or power of 5, sometime power of 5, sometime power of 2, and sometime power of both. Okay, is that clear? Q 2 square, that means power of 2. Q 5 square, power of 2. Q 5 square, power of 5. Here Q power of 2 and power of 5, both. So finally what I'll write, the property that Q must satisfy is that, what is that? Is that the prime factor, these are prime factorizations, the prime factorization, prime factorizations of Q, this prime factorization, these are prime numbers, so 2 and 5 are prime numbers, and these are in factors. You understand the factor? 10, I can write 2 into 5, so these are factors. 2 and 5 are factors of 10, and these are prime factorization because 2 and 5 are prime numbers, a number which is not divisible by any other number except 1 and itself. Okay, so prime factorization of Q, this prime factorization of Q must have only powers of 2, we have seen 2 or 5, sometime 2, sometime 5, or power of 5, what am the power of both 2 and 5. So this is my answers. If you understand, let's go to example 7. Write three numbers whose decimal expansions are non-terminating, non-recurring. Before I do, let me give a brief idea of irrational number again. Okay, irrational number we have already done. If you have not watched it, please go back and watch the introduction part of this exercise. Irrational number in decimal expansion is the format. Okay, 0 point, any number you can take 0 1. See the sequence 0 1 0 0 1 0 0 0 3 zeros 1 0 0 0 0 4 0 1. Why I am writing this? Irrational number are actually non-terminating. See, these are not terminating. There is no ending. First part, first condition, non-terminating. Okay, terminating. Second part, non-recurring. So these are the two conditions required for any decimal expansion to be an irrational number. Okay, so this is non-terminating, and second, non-recurring also. No numbers is repeating in certain pattern. Okay, 0 1, then 0 0 1. See, 0 1 is not repeating again. 0 0 1 is not repeating again. 0 0 1 is not repeating again. Is that clear? Okay. So write three numbers whose decimal expansions are non. That means we have to write three irrational number. Non-terminating and non-recurring means irrational number. We have to write three irrational number. So first one is this one. This is my irrational number. Okay. Second one will be similarly. You can use 0 2 0 0 0 2 0 0 0 2 0 0 0 0 2 dot dot dot. So this is my second. Third one you can write 0 0.03 0 0 0 3 0 0 0 3. Now 0 3 again. This number is not repeated. You should write a number which is not repeating. 0 3 should not repeat. So I have taken 0 0 3. Again here 0 0 3 should not repeat. So I have taken 0 0 0 3. So dot 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 dot. Okay, so these are the three irrational number. Right, so let's do question number 8 quickly. Find three different irrational number. Again irrational number. See, between the rational number 5 by 7 and 9 by 11. That means 5 by 7. What is this? If I divide, I'll write directly the answer. You can divide it yourself. 5 by 7 I can write 0 point. This is rational number 7. So decimal expansion should be repeating and non-terminating. 7 1 4 2 8 5. Okay, again 7 1 4 2 8 5. So like this it will keep on going. So this is my 0 0.714285 repeating. Okay, bar. So this is my 5 by 7 and 9 by 11. If we divide, you'll get 0 0.818181 dot 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 dot. That means 0 0.81 bar. So these are the two numbers, two rational number which I have got. In between these two, I have to find three irrational number. Now we know in the previous questions that what is irrational number. Like you should follow certain pattern, like 0.01. So 01 should not repeat. Okay, non-repeating. Irrational number is non-repeating, whereas rational number is repeating. This is the difference of irrational and rational number. So 01, I should not write 01, so I'll write what? 0 0 1, 2 zeros. Again, not to make this repeat, I'll write 3 zeros. Like this it will go on. It's non-terminating, at the same time non-repeating also. This is irrational number. So I have to insert three this type of numbers in between this two rational number. One is this one and the other one is this one. Okay, so let's do this one also. Before I write the irrational number, let me understand the small part of this number. See, let's see here, 71. Can you see 71? Forget the rest of the number. Just take two digits after decimal expansion, decimal point. 71. Here 81 after decimal point 81. So let me write 71 and then 81. Okay, obviously 0.1, 0.7. Okay, now 71 and 81, in between these two, what are the numbers I have? Can I have this 72? Can I have 73? Can I have 74, 75, 76? So many numbers. 77, many numbers I can have. All right, but I'll focus on only three irrational number. Three irrational number I need. So what I'll do, I'll take only three. I'll start only with three. The first one is 72. Okay, so 0.72 here also, 0.73 here also, 0.74. So first irrational number, okay, that can be taken in between 5 by 7 and 9 by 11 is the first one. First one, what is the first one? 0.72. All right, see, after 0.72, so not to make this repeat, what I'll take, I can take 0.072, again 2.2072, 3, 1, 2, 3, 7, 2. So like this it will keep on going. Only you take the first two digits, second one, okay, second one, okay, the second one I'll take 0 point, I'll start with this 7.3 now, 7.3, again 0.73, 2.073. So like this it will keep on going. Third one, okay, what is the third one? 0 point, this third one, 7.4, 7.4, again 0.74, again 0.074. More you can take 0.0074, but I'll not take. So these are the three irrational number lying between 5 by 7 and 9 by 11. All right, I think you have understood. So let's go quickly to question number 9. So in question number 9, classify the following numbers as rational or irrational. So here you have to see which one is rational and which one is irrational. See here, this I can write, this root I can take 15. So this is my rational number, simple. Rational number. This one, if you see properly, 478, 478 is repeating. That means this I can write 7.478 on top of this bar. This is repeating. So this is also rational number. This is terminating. This is also rational number. What about this root? I cannot take out this root 23, but if you take out also, you'll get like this. See, I'll just show you. 23 you can take, and if you divide it, if you take out the square root, 4.79583152, 3 you will get. Okay, and then dot 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 dot. Since the decimal expansion is non-terminating, it's not ending, non-terminating, also non-recurring, not repeating. You tell me what number is this? Therefore root 23 is an irrational number. Very easy. So with this, we'll come to the end of this exercise. I've done all the questions. In the next class, I'll see the next exercise, that I'll do exercise 1.5. Till then, see you. Have a good day. Thank you for watching, and keep watching my other videos to get all the details of all the chapters. Thank you so much.